This lesson is polar equations of conics. I will do two parts. This is the first part and then the second part because the lesson is very lengthy. So I will break it up into two parts. So here is polar equation of conics. You have two forms, one for sine, one for cos. Each one of them have plus and minus. So technically there are four versions of this, okay? But in general, it's just sine and cos. One for plus and minus, the other also have plus and minus. So there are four of these, okay? But in general, it's just sine and cos. Now, some textbook have ED, other textbook have EP. It is the same thing, just different variable. So don't get confused between D and P, okay? They are the same thing, just different variable, okay? So with conics, polar equation and conics, these are the three things we have to worry about. E, it stands for eccentricity. If E is between 0 and 1, you have ellipse. If E is equal to 1, you have parabola. If E is greater than 1, you have hyperbola. So be very careful with E. Now with E, again, E stands for eccentricity. You have three versions of these. From 0 to 1, you have ellipse. Equal 1, parabola. Greater than 1, you have hyperbola. Now with ellipse and hyperbola, E is equal to C over A. Now this, you only use this if you are in ellipse or hyperbola. One more time. You only use this if you are in ellipse and hyperbola. Okay? So here is the four version of these for plus and minus sine, plus and minus cos. So let's do plus and minus sine first. So if I have a plus, then it is face down. Your directric will be on top. One more time. If it's plus sine, your graph will be face down. Your directric should be on top. Okay? And then if you do the graph, you will have 0 degree, 90 degree, 180, 270 degrees. You will use these 4 points, use these 4 degrees to graph. Okay? All right. Now, from directric to the pole, which is this guy right here, the x-axis, will be your the distance from the directric to this axis. Okay? F will be your focus. The big D is your directric. Okay? Now, this is for plus. Now, if this is minus, then it is the reverse. The graph will face up. Your directric will be in the bottom. Since it is in the bottom, your directric has to be a minus. Okay? One more time. Let me zoom out. If it's plus, if it's plus, your graph will face down. Your directric will be on top. So directric will be plus, positive. If it's minus sign, your graph will face up. Your directric is in the bottom, so therefore directric is minus, okay? You will continue to use 0, 90 degree, 180, 270 to get your points so that you can graph, okay? So these are the two versions, one for plus sign, one for minus sign, okay? Plus, face down, minus, face up. This is for sine only. This is only for sine. Okay. Now let's do for the plus and minus cos. So here's plus and minus cos. If I have plus cos, it will face to the left. Your directric is on the right side, and since it's on the right side, it is positive. If this is minus cos, then your graph will face to the right side, and your directric is on the left. And since it is on the left, directric has to be minus. Okay? Again, you're still using 0, 90, 180, 270 to graph. Okay? All right, so here we go. Let me do it again. Show you the plus and minus. Plus sign face down. Minus sign, face up. Okay? Plus cos, face left. Minus cos, face right. Okay, so those are the four versions of plus and minus sign and plus and minus cos. One more time. Plus sign, down. Minus sign, face up. Plus cos, left. Minus cos, right. Okay. Also, don't forget about the E. This will determine if it's ellipse, parabola, or hyperbola. Okay. All right, so here is our first example. R equals 6 all over 2 minus cos theta. Now, according to our general equation, the first number must be a 1. This is by default. This must be a 1. Same thing over here. This must be a 1. This is by default. So here I have a 2. Here I have a 2. So the only way to get a 1 here is we're going to divide by 2 to the top and also to the bottom. Whatever this number is, if this is a 2, divide by 2. If this is 3, divide by 3. If this is 8, divide by 8. Whatever this number is, you will divide by that number. Why? Because we need a 1. We need to be a 1. Again, whatever this number is, divide by that number. If this is 3, divide by 3. If this is 8, divide by 8, and so on. Since this is 2, divide by 2. So divide by 2 to the top, which I have here. So 6 divided by 2. Divide the 2 to the bottom. 2 divided by 2. Cos theta divide by 2 to all of it. Okay, so 6 divided by 2. 2 divided by 2. Cos theta divide by 2, which I have over here. Okay. So this is just simple algebra. 6 divided by 2 is 3. 2 divided by 2 is 1. Cos theta over 2. We'll just bring the 1 over 2 to the outside. Okay, 1 over 2 on the outside. Okay, so we can do that. Bring the 2 out. Okay, which I have right here. So imagine that there's a 1 right here. So 1 over 2, just bring it out. Okay, again, we need this to be a 1. And the reason why we need this to be a 1 so that we can know what E is. One more time. The main purpose of this must be a 1 so that we know what E is. We know what E is. Okay. If you look very carefully, our original equations, our general equations, here's 1, here's E. That's the reason why we need this a 1 so that we can get E. Okay. So according to this, I'm going to bring this equation. I'm going to bring this equation up here. Okay. I'm going to bring this equation right here up here. Okay. So let's find out what E is. E is 1 over 2. Okay. E is 1 over 2. According to our eccentricity, it is between 0 and 1 because a half is between 0 and 1. So this right here is an ellipse. So that's how this is how you identify polar equation of conics if it's ellipse, parabola, or hyperbola. One more time. This is how you identify polar equations of conics if it's ellipse, hyperbola, or parabola. Okay, so again, this E right here is right here. If it's between 0 and 1, ellipse, equal 1, parabola, greater than 1, hyperbola. Okay, and with ellipse and hyperbola, you will use this equations to get CA. Okay, all right, so we know that E is 1 over 2, which is right here. And 1 over 2 is between 0 and 1, so it is an ellipse. Next, we need to find out what D is. So on top will always be ED. On top, whatever that number is, it is always equal ED. One more time, the top number will always equal ED. Well, we know what E is, which is 1 over 2. So let's solve for D. By multiplying a 2, the reciprocal of 1 over 2 is 2. So 2 times 3, 2 times 1 over 2. Okay, just multiply the reciprocal of this. So 2 times 3 is 6. 2 times a half is just 1. So D is 6. Okay, so what is D? D is the distance. D is the distance, okay, where you can get your directrix. Okay, so D is the distance from the x-axis or wherever the pole is to the directrix. So that is the distance from the pole to the directrix. Okay, so that's what D is. So we know what E is. Now we know what D is. Okay, so next we need to find the points. Next we need to find the points. Okay, we need to find the points. So using 0, 90, 180, 270. Again, you will always use 0, 90, 180, 270 to get the points. Okay, to get the points. Okay, so theta, okay, which is your degrees, r, which is using the original equation right here. Here's my r. Okay, so using theta, 0, 90, 180, 270. Use these 4 degrees to get my points. Okay, so as you can see, r, which is my original equations. Okay, so all you have to do is just plug them in. So put 0 in. So put 0 in for cos. Well, what is 0 for cos? Cos 0 is 1. If you put this in your calculator, cos 0 is 1. Okay, so 2 subtract 1 will be 1. 6 divided by 1 is just 6. One more time. Cos 0 is 1. 2 subtract 1 is 1. 6 divided by 1 gives me 6. And so on with the rest. Okay, so if you put 90 in cos, 90 in cos, okay, so put 90 in cos, which is 0. Okay, so 90, cos 90 is 0. 2 subtract 0 is 2. 6 divided by 2, that gives me 3. And so on with these two numbers. Okay, now we know these 4 values. Now just graph them. Okay, so 0, 6. So 0, 6 is here. Okay, 0, 6, which is here. 0, 6, which is here. 93, 93, right here. 182, 182. Okay, 273, 273 here. Okay, so that's how you get these 4 points. Okay, so 0, 6 here, 93 here, 182 here, 273 here. Now one more time, always use 0, 90, 180, 270 so that you can start to get a graph much easier. Okay, so you can get the graph much easier just using these 4 degrees. Okay, so and then from here I will explain to you where did I get this, where did I get this, what is my F1, F2, A, B, and C. For now we just need these 4 points so that we can get the ellipse. Again, what I have here is just a rough sketch approximation. It is not a perfect accurate graph. Okay, so we just need these 4 points to start my graph. Okay, all right, so here's my, and as you can see, if you look very carefully, this is a minus right here. This is a minus, so your graph did face to the right. Since this is a minus, your graph did face to the right and your directrix is on the left side. How do I know that? It's from here. Here's minus cos. It faced to the right and my directrix is on the left side. Okay, and since the directrix is on the left side, it has to be -6. Okay, this D right here means the distance from the directrix, okay, from the directrix, okay, to the pole. Here's the pole right here. Here's the axis right here. From here to this axis right here, it is 6 units. Okay, so again, D is the distance from the directrix to the pole. Okay, so, and since it is facing to the right, your directrix has to be on the left side. So from here to here is the distance from the directrix to the pole. And since the directrix is on the left, it has to be -6. Okay, all right. So next, we need to find out. So that is a rough sketch. Okay, again, use these 4 points. Okay, just use these 4 points so you can get a rough sketch of the graph. Okay, next, we need to find the major axis, and the major axis is from left to right. Now, if this was vertical, then your major axis will be from top to bottom. Okay, so again, because this is horizontal, your major axis is from left to right, and your minor axis is from top to bottom. Now, if this was reversed this way, vertical, if this was vertical, then your major axis will be top to left, and your minor will be left to right. Okay, again, because this is horizontal, your major axis is from left to right. Your minor is from top to bottom. Okay, so major is the longest side, minor is the short side. Since this is horizontal, your major is left to right, minor top to bottom. If this was vertical, if this is horizontal, if this was vertical, then your major will be top, bottom, and your minor will be left to right. Okay, again, this is horizontal, so my major is very simple. All you have to do is just take 6, here's your vertex, 6, subtract -2, 6, subtract -2, and your major axis is 8. Okay, all right, so either that or you can do this too. Okay, so major axis is always 2a, and we know that the distance is 8. So your major axis is 6 subtract -2, which come out to be 8. Okay, but we want to know what a is. Okay, so our major axis, again, our major axis is 6 subtract -2, which gives me 8. Okay, but we need to know what a is. We need to know what a is. So major axis is always by default 2a. Okay, 2a equal 8. Where did I get this 8? Because from here to here is 8 units, and you can really count that. Here's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so just find a, and major axis is always 2a. So 2a equal 8, divide by 2, a is 4. Okay, so a is 4. So what is a? A is from the center to the vertex. That is 4 units. A is from the center to the vertex is 4. Same thing on this side. From the center to this vertex is also 4. Okay, so center to here is 4 units. That's my A. Okay, now to get the center, it should be really easy. All you have to do is just count them. So here it is. 1, 2, 3, 4. There's my center. 1, 2, 3, 4. So again, that's my center. Okay, so since A is 4, okay, you can do this from vertex 1, 2, 3, 4. That's my center. Okay, one more time. A major axis is always 2a. Divide by 2 gives me 4. Okay, so from the vertex 1, 2, 3, 4. Okay, so that's my center. My center is right here. Okay, from here to the vertex is 4. Same thing from to left side. From the center to the left is also 4. Okay, now we need to find, because this is ellipse, we need to find C. We need to find C and also B. C is from the center to the focus. The distance of C is from the center to the focus. Okay, again, C is from the center to the focus. Okay, the distance of C is from the center to the focus. So how do I get C? using this equation right here. By default, E is equal to CA. Well, we know what E is. E is 1 over 2. We know what A is. A is 4, which we found out here. So E is 1 over 2 equals C over 4 because A is 4. So all you have to do is just cross multiply this. So 1 times 4 is 4. 2 times C is 2C. One more time. 1 times 4 is 4. 2 times C is 2C. Just divide by 2. So C is 2. Okay. So the distance of C is from the center to the focus. So here's my first focus. This is how you find the focus from the center, 2 units to the right. 2 units to the left, which is my first focus. 2 units to the right, which will be my second focus, because ellipse must have 2 focus. Okay, so one more time. The distance of C will determine the focus. Okay, so from the center, 2 to the left will be my first focus. The center to the right will be my second focus. So that's how I find my focus, using the distance of C. Okay, again, how did I get C? C is 1 over 2. E equals CA. We know E is 1 over 2. CA. So put the E in, which is 1 over 2. A is 4. So cross multiply gives me 4. Cross multiply gives me 2C. Divide by 2 gives me 2. Okay. So again, C is the distance from the center. And then that's how you will find your focus 1 and focus 2. Again, center. C is 2 to the left, first focus. Center to the right, second focus. Okay, so that's how I find C and find A. Now I need to find B from the top vertex to the center. Okay, so to get B, you will always use this formula in ellipse. To get B, you use this formula for ellipse. C squared, okay, equal A squared minus B squared. So just plug these numbers in. Okay, just plug these numbers in. We know what A is, which is 4. We know what C is, which is 2. So 4 squared is 16. 2 squared will give me 4. 16 subtract 4 will give me 12. Well, we don't want square. We want the square root. So square root of 12, which is 4 times 3. So square root 4 is 2. Square root 3 is just square root 3. So B is 2 square root 3. So this is the distance of B. So where is B? From the center to the top vertex. That is the distance of B. Same thing on the bottom. From this center to the bottom of this will be the vertex of the other side of B. Okay, so distance of A is from center to the right, center to the left. Distance of C from center to get me my first focus, center to get my second focus. Okay, B, center to the top vertex, center to the bottom vertex. So that's how I find the distance of A, distance of C, distance of B. Okay, so again, A is 4, C is 2, B is 2 square root 3. Okay, now to get my minor axis is just 2 times B. So here's B. To get my minor axis is just 2 times B. Okay, so 2 times B, well, we know what B is, 2 square root 3. So times 2 to it, I get 4 square root 3. Okay, so that's how you find your major axis, your C, your your B, your A, your C, your B, and then your minor axis. Okay, so be very careful when you do this. Okay, so this is the first part. Now we have a second part. Okay, so again, this is just the first part. So let me zoom out so you get the whole note.